All right, so we're doing question number 3, and we set up the coordinate system first, and at point A the charge is plus 2 nanocoulombs, and at point B the charge is plus 8 nanocoulombs. So first the question asks for A, what is the electric force that the plus 2 NC charge exerts on the plus 8 nanocoulombs charge? And so we used this force equals the constant times QA times QB over r squared, the radius in between. So first you plug in your numbers, the constant, and then the two charges for A and B, divided by our radius squared. And then we have to convert nanocoulombs to coulombs here so that we have everything in the correct units, and then also to meters. And then once this is solved, it equals 8.99 times 10 to the negative 5th nanocoulombs. Significant digits, 9 times 10 to the negative 5th nanocoulombs. And then also the second part of the question asks the electric force that the plus 8 charge exerts on the plus 2 charge. And it's exactly the same thing because of the commutative property of multiplication. So basically if you flip these, they're going to be the same answer. It's just the direction changes. So for the force that A exerts on B, it's to the right, and for the force that B exerts on A, it's to the left. And this has to do with Newton's third law.
For part C, we're going to find the magnitude and direction of the electric force exerted on the location of point B from point A. So what we do, we have this formula, which is kind of a watering down derivation of Coulomb's law. We have our constant times our point charge divided by the radius squared. So here's our constant, here's the charge of point A, and here's its distance away from point B. And so we get 1.13 times 10 to the negative 4th newtons per coulomb. And this is going to be in the right direction because this is a positive charge. It doesn't matter what this charge is because we're only worried about the force of the electric field at that location. Now as for the charge that point B exerts on the location of point A, same thing, we have our formula, our constants. Here's the charge of point B and the distance away from point A, and we get 9.00 times 10 to the negative 5th newtons per coulomb. Again, since this is a positive charge, it's exerting force this way, so it's going to be to the left. So the final question is, in light of our answers to both A and B, where the charges, the forces are pointing in an equal and opposite direction, do these answers make sense? Because we got 9.0 times 10 to the negative 5th going this way, and then 1.13 times 10 to the negative 4th going this way. The reason it does make sense is we're not figuring out the charges they exert on each other. We're just figuring out the charge that this would exert on this location and vice versa. It's as if these points aren't even there. We're just figuring out the magnitude and the direction of the electric field, not the effect on the charge themselves.